Maths, presented by Fatima Convent High School, Chapter 5, Class 10, Arithmetic Progression. Now, we all are familiar with a number of events happening together, one after the other, or a sequence of events. We are going to study something related to this sequence or a series of events occurring one after the other, and that also with numbers. You must have observed that in nature many things follow a certain pattern, such as petals of flowers, a hole of a honeycomb, the grain of a maize cob, the spirals on an apple, pineapple, and a pine cone, etc. We now look for some pattern which occurs in our day-to-day life. Some such examples are: Reena applied for a job and got selected. She had been offered a job with a starting monthly salary of 8,000 with an annual increment of 500 in her salary. So it's very obvious, we all can calculate this very easily, what would be her salary each month. That is, her salary in rupees for the first, second, third year will be respectively 8,000, 8,500, 9,000. The length of the rungs of a ladder decreases uniformly by 2 cm from bottom to top. The bottom rung is 45 cm in length. The length in centimeter of first, second, third up till 8th rung from the bottom to the top are respectively 45, 43, 41, 39, 37, 35, 33, 31. So you can see that difference between any two number here is 2. And now third example we take, in a savings scheme the amount becomes 5/4 times of itself after every 3 years. The maturity amount in rupees at an investment of 8,000 after 3, 6, 9 and 12 years are respectively 10,000, 12,500, 15,625 and 19,531.25. So you can see how the patterns of numbers according to the given description. The number of unit squares in squares with sides 1, 2, 3 units as seen in the figure are respectively 1 square, 2 square, 3 square. Same way, Shakila puts rupees 100 in her daughter's money box when she was 1 year old and increases the amount by rupees 50 every year. The amount of money in rupees in the box on the first, second, third, fourth birthday were 100, 150, 200, 250 respectively. Now there is a very interesting experiment and an example here which you might study in biology. A pair of rabbits are too young to reproduce in their first month. In the second month, every subsequent month, they produce a new pair. Each new pair of rabbits produce a new pair in their second month, and in every subsequent month, assuming no rabbit dies, the number of pairs of rabbit at the start of first, second, third till 6 months respectively are 1, 1, 2, 3, 5, 8. How? Now there is one mother rabbit and one father rabbit giving birth to a pair of rabbits. Now these pair of rabbit in the first month is giving birth to 2 more rabbits. Now in the second month, this mother-father reproduces to give 2, then 3, one more pair and one more pair. Now this newly born baby of the first parent again gives birth to a new baby pair, a new baby pair and a new baby pair. The pair of rabbits given birth by the mother and father in the second month, they also reproduce. and give birth. Same way, here also they reproduce. Every rabbit which is born from the mother and father keeps on giving birth, and the total number of rabbits at the end can be calculated easily. In the example above, we observe some patterns. In some, we find that the succeeding terms are obtained by adding a fixed number, in other by multiplying with a fixed number. In another, we find that there are squares of consecutive numbers and so on. In this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to preceding terms. We shall also show how to find their nth term and the sum of n consecutive terms and use this knowledge in solving our daily life problems. Now let us see what is arithmetic progression. So these type of events which we saw in the case of rabbits, in the case of money matter and savings, or even in the case of any ladder, there is an increasing or decreasing pattern. This pattern of numbers is called as arithmetic progression. Now consider the list of number 1, 2, 3, 4 till infinite. Same way 100, 70, 40, 10, minus 3, minus 2, minus 1, 0 and so on. 3, 3, 3, 3. Minus 1 and 0, minus 1.5, minus 2.0, minus 2.5. Each of the numbers in the list is called as term. Very important definition this is. So you can say 100, 70, 40 and 10. They are terms. Given a term, we can write the next term in each of the list above. If somehow, will you write it? Perhaps by the following pattern or rules. Let us observe and write the rule. In first one, each term is more than the other preceding term by 1. So here it is 1, 2, 3, 4. Obviously, this you have been doing in lower classes. We know that the next term will be 5, 6, 7, 8 and so on. Same way, if you see in the second one, there is a difference of 30 between the two terms. That is here 30, then here 30 and here 30. So I know what will be the next one, right? It would be a negative number, but there is a difference of 30. So it will be minus 20. If I still go further, it will be minus 50. So on. Same way next, we have a difference of 1 being added. So it will be 1, 2, 3 and so on. Same way, it is a repeating unit with 3, that is each term is obtained by adding or subtracting 0 to the preceding term. And in fifth, each term is obtained by adding minus 0.5, that is subtracting 0.5 from the term preceding it. In all the list above, we see the successive terms are obtained by adding a fixed number to the preceding term. The list of numbers is said to be an arithmetic progression, which in short we'll use as AP. So, an arithmetic progression is the list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called as common difference of the AP and is denoted by term D. Remember that it can be positive, negative or a 0. That is, D can be equal to 0, D can be less than 0 and D can be greater than 0. Let us denote the first term of an AP by A1, second by A2 till nth term by AN and the common difference by D. Then the AP becomes A1, A2, A3 till AN. So D is nothing but A2 minus A1 is equal to A3 minus A2, so on till AN minus 1, that is equal to D. Very important formula this is. Some more examples of AP are height in centimeter of some students of a school standing in a queue in morning assembly are 147, 148, 149, 157. The minimum temperature in degrees Celsius recorded for a week is month of January in a city arranged in ascending order are -3.1, -3, -2.9, -2.8, -2.7, -2.6, -2.5. The balance money in rupees after paying 5% of the total loan of rupees 1000 every month is 950, 900, 850, 800, 550. The cash prize given by a school to the topper of classes 1 to 12 are respectively 200, 250, 300, 350, 750. The total savings in rupees after every month for 10 months when 50 are saved each month are 50, 100, 150, 200, 250, 300, 350, 400, 450 and 500. In the left as an exercise for us to explain why each of the list above in an AP. You can see this, that is A plus D, A plus 2D, A plus 3D. Represents an arithmetic progression where A is the first term and D is the common difference. This is the general formula for an AP. Now there is an example A and E above. There are only a finite number of terms and so it is called finite AP. And also note that each of the term of this arithmetic progression has a last term. This whole terminology is very important in this chapter. The AP is example 1 and 5, 1 to 5 is in this section are not finite AP. They are called as infinite arithmetic progression. They do not have a last term. Now to know about an AP, what is the minimum information that you need? So to check whether it is an AP or not, is it enough to know the first term or it is enough to know only the common difference? You will find that you will need to know both the first term and the common difference. So to check whether a given series or a sequence is an AP or not, then we need to check whether it is having a last term as A and a common difference D. For instance, if the first term A is 6 and the common difference D is 3, then the AP is 6, 9, 12, 15. And if A is 6 and D is -3, then AP is 6, 3, 0, -3 and so on. Similarly, A is -7 and D is -2, then the AP is -7, -9, -11, -13. A is 1.0, B is 0.1, the AP is 1.0, 1.1, 1.2 and 1.3. A is equal to 0, D is 1 integer 1 by 2, the AP is 0, 1 integer 1 by 2, 3, 4 integer 1 by 2 and 6. A is 2 and D is 0, the AP is 2, 2, 2. So if you know that A and D, you can list the AP, means you can make a new AP. What about the other way round? That is, if you are given a list of numbers, can you say that it is an AP and then find A and D? Since A is the first term, it can easily be written. We know that it is an AP. Every succeeding term is obtained by adding D to the preceding term. So D found by subtracting any term from its succeeding term, that is, the term which immediately follows, it should be same from AP. For example, for the list numbers 6, 9, 12, 15, we have A2 minus A1 is 9 minus 6 is equal to 3. Always remember it should be last term, preceding term and succeeding term. So succeeding term minus preceding term. A2 minus A1, A3 minus A2, A4 minus A3. That is 12 minus 9, 3 and 15 minus 12 is equal to 3. Here the difference of any two consecutive term in each case is 3 and so the list A given list is an AP whose first term A is 6 and common difference D is 3. For the list of numbers 6, 3, 0 and minus 3, A2 minus A1 is equal to 3 minus 6 is minus 3, A3 minus A2 is equal to 0 and minus 3 is equal to minus 3, and A4 minus A3 is equal to minus 3 and minus 0 is equal to minus 3. Similarly, it is also an AP whose first term is 6 and the common difference is minus 3. In general, for any AP A1, A2 till AN, we have D is equal to AK plus 1 minus K, AK, where AK plus 1 and AK are the K plus 1th and the Kth term respectively. To obtain D in a given AP, we need to not find all A2 minus A1, A3 minus A2, A4 minus A3 and so on. It is enough to find only one of them. Consider the list of number 1, 1, 2, 3, 5. By looking at it, you can tell that the difference between any two consecutive term is not same and so it is not an AP. Note that to find D in the AP 630 minus 3, we have to subtract 6 from 3 and not 3 from 6. I said the order of the term is very important. We should subtract the kth term from k plus 1th term even if the k plus 1 is smaller. Let us now make the concept more clear through some examples. Before that, let us summarize what we understood till now. So, what is AP? AP stands for Arithmetic Progression. A stands for first term or A1. Letter A represents term, D represents common difference. AN represents number of term. Now the formula for AP is A plus D, A plus 2D, A plus 3D and so on. Formula for D is A2 minus A1 or AN minus 1 minus ANth term. This is what D stands for. So, for the first part of the chapter, we are going to check whether it is an AP or not. And second, to make an AP. Or form an AP. For that, for checking an AP, we just need to check A, that is the first term, and D for the AP. Means D should be same for all terms. And to form an AP, we need A and D, and we can form an AP by the formula A plus D, A plus 2D, A plus 3D, and so on. Now let us look into the example. Example 1. For an AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. Write the first term A and common difference. Very simple. First term is 3 by 2. Common difference is A2, that is A2 minus A1, which is equal to 1 by 2 minus 3 by 2, that is minus 1. Now, remember that we can find D using any two consecutive numbers once we have that number in the AP. Now, we have to check in the next question whether it is an AP or not. To check that, we need to check the common difference between the terms. So, for the first one, 4, 10, 16, 22, let us check. A2 minus A1 is 6, A3 minus A2 is 6, and A4 minus A3 is also 6. Therefore, it is satisfying the condition for D, that is A k plus 1 minus AK in the same every time, and so it is an AP. Now in second one, it is minus A2 minus A1 is minus 2, A3 minus A2 is minus 2, and A4 minus A3 is also minus 2. Hence, this 2 is also satisfying the conditions for it to be an AP. Same way, for third one, A2 minus A1 is 4, but A3 minus A2 is minus 4 and minus 9. Means A2 minus A1 is not equal to A3 minus A2. Therefore, it is not an AP. This is how we check whether it is an AP or not. So, A2 minus A1 is equal to 1 minus 1 is 0. Fourth one, A3 minus A2 is 0, A4 minus A3 is 1. Means first is satisfying, but the last is not satisfying. This also is not an AP because common difference should be same. I hope this much is clear. In the next session, we are going to do exercise 5.1. Thank you.